afternoon, everyone. Thank you so much for a nice introduction. I hope that you enjoyed the lunch. I'm so glad for the opportunity to be here and talk about such interesting topics as compliance and the connection to robot framework. So let me first introduce the agenda. So at first, a small introduction about me, about the background, where I work, and why I actually chose the topic of compliance. Then we will have a look at what is actually compliance and some definitions and what is SDLC. Then I will try to outline the problem statement, like why I am actually here and why I decided to give this speech. Then let's see how we can use robot framework as a compliance enabler, and in the end we will conclude with some summary and key takeaways. So for the introduction, who am I? So my name is Katerina Hosova. I came here from Prague, beautiful city in Czech Republic. I work as a software engineer and automation test engineer for more than 7 years in a company called MSD. MSD is actually a pharmaceutical company, which is a part of a regulated environment. What does it mean? It means that we have a lot of regulations, a lot of policies that we need to follow, and that we need to build our software on top of what the regulations and policies tell us to do. So let me start. What is actually compliance? So by the Gartner definition, compliance is a process in which you need to adhere to those policies which come either from internal directives or from external laws. With this, the development teams that work in this regulated environment, they try to find some compliance enablers that are tools or some projects or some processes that help them deal with this whole compliance, huge, complex process. These can be activities including verification, validation, documentation, sign-offs, or regulatory submissions and approvals. This whole process usually leads to a very extensive list of documentation that you need to fulfill in order to be able to actually release a product increment into production environment. And all those actions that are done during the software development lifecycle, or shortly SDLC. So what is actually software development lifecycle? If you have a look into the image, this is a very high level and simplified one. It consists of multiple phases. Each of the phases needs to be very well described and contains like an extensive list of documents that you need to fill in. It's continuous loop. It means that you don't have to fulfill it only once and then just move on and release whatever, however you want to, but you need to go through this loop with each of the product increments. So let's start with the first phase. It's called requirement or planning phase, which is the first one on the top. And I will describe at least the high level and like the elementary documents that you need to fulfill in order to be able to release. So first of them is a quality assurance plan, which is a document which defines the criteria, what the scope of the product is or the product increment is, what are the documents and the activities you need to perform in order to be compliant. And basically, it's like the whole plan of like scheduled things from development, design, testing, and then the release. The next document is a requirement specification, which is a list of both functional and non-functional requirements. Those have its own acceptance criteria. Then you need to take those acceptance criteria and build the tests on top of them. So it means that you should test whatever the requirement says, like that the product should do. And last but not least, the development test plan, which contains the description of your development and testing processes. It contains how the collaboration between the team members will go, and it lists their roles and the timelines of the project. The next phase, I actually combined two together. It's a design and build phase. And in this one, there are two major documents. First of them is design specification. Design specification describes what actually the application or the project or the piece of software should do and what it should present. It describes the technical implementation of the features, and it serves as like a cookbook for the tester upon which the tester should create the test cases. And on top of that, there is a test plan, which lists the types of conducted tests. The test scenarios drafting starts. So once you obtain the acceptance criteria in the requirements, you can start with the actual test drafting. The third stage is the testing phase, in which the actual tests are conducted. The test results are being stored, and you get the test artifacts that you then need to store in some approved storage. And from the test results and from the requirements, you will get the requirements traceability, or you need to create the requirements traceability, which basically maps out the test coverage per the requirement, and which serves as like a go, no-go decision for the product in order to be released. And last stage is the actual delivery. There is one major document called the Quality Assurance Summary Report, which is like a sibling document to the Quality Assurance Plan, and it lists what actually happened. It lists the evaluation of the test results, whether you successfully released or deployed to production, or in case there's something wrong happened, why it happened, or if you created any incident for that to be resolved. So what is actually the problem here? First and foremost, software developers don't like documentation much. It's like very extensive. It's not popular. You need to go open up the Word template. You need to fill in the data manually. You need to copy-paste from other sources. You need to fulfill what is actually done by the policies. So you can't just like really write whatever you want to, but you need to go like step by step what the policy tells you to do. And the policies are really hard to navigate through. It's usually like a 10, 20, even 100 pages long document, which you need to read, then you need to understand it, because it's usually not really easy human readable language, and then you can only create the document. As I said, the Word templates needs to be filled in manually, so there is like a high chance that you will do an error. Like, we are humans, we can copy-paste something different, no one will notice, and it will be just approved and stored. And last but not least, there are actually three parties cooperating during this whole process: technical, business, and quality. The technical unit is like a technical person who is responsible for the solution, meaning developer, some subject matter expert, or even the tester, whoever is part of the development team. Then the business unit is a stakeholder representative. It's the person who makes sure that what you created actually fulfills what was the idea and it does what it's intended to do. And then the quality unit, it's a compliance representative who makes sure that it meets the quality criteria. What happens if you don't fulfill the criteria? Well, the consequences can be like from legal ramifications. You can pay some financial fines. There might be reputational damage for the company and so on. It's a very complex process. Usually people don't know where to start. So let's see if we can find some way how to improve at least a little bit of this whole SDLC. And how we can leverage robot framework to do that. We started with the testing phase, because in testing phase, if you are using robot, you basically run some pipeline, which is used for the automation, and then the pipeline can actually produce at least a part of the documentation for you. And those audit-ready documents that will be produced will automatically adhere to good documentation practices, which is like remain data integrity, the information needs to be accurate, and you need to have it stored in some approved storage where it's easily accessible on demand, and the retrieval is easy in case some auditor comes and wants to see the proof. Let me start with some good practices for writing the test scenarios. I think it goes well hand in hand together with the previous presentation with the gherkin. First thing you should keep in mind is to increase the readability of the test scenarios. You should avoid using some technical terms because you always need to keep in mind that the test scenario will be read by a person who is non-technical. So it means that they need to really understand what you meant by this test scenario. What is the outcome that you should get from this test, if it's passed or failed, and what actually is the story and acceptance criteria behind. You should avoid including variables inside like all of those test steps. You can have them like inside in the nested structure of the keywords, but should avoid using them on this like the highest level. Don't forget to include documentation because the information you put in there, it should be like what the test is testing. It should describe the purpose of the test, and it will be then taken into the final report. Then for the requirements linkage, you can use force tags in the settings section. Those can be IDs of the requirements, or it can be ID of the Jira story if you are using Jira, and then it will be also embedded in the final report file. What would be the outcome? And after that, I will tell you how to get there. So the result report file should be easy to navigate. It should be easily printable. It means that if it fits into one page, if possible, that would be great. But you can have, of course, multiple tests. But it should be easily identified, so it should include some identificator. It can be name of the test suite or whichever name you feel like it can be name of the feature. Then it should include some metadata about the test execution. Those are the minimum information that should be included all the time. It's the status of the tests run, its starting and end times, timestamps, name of the application and the version identifier, called release there, name of the tester or the tester tool that you use, and scope of this release. So you can, or the person, the auditor, can come and easily see what is actually tested there. Then some easy statistics, which will determine the go, no-go situation. It can be like a quality gate. You can see I chose a failing example, so you can see if I would be, for example, the business unit, I would look into the report and say, hey, there is something wrong. I can see red failure, do something about it. We cannot release like that. It should also include the number of the tests, if there were any skipped, because you need to file those as well, just to be sure that you didn't skip anything that needs to be tested in the scope. And then the test statistics, those can serve as a requirements traceability, because those requirements that we put into the force tags can be used in those requirements table. And it can be even transformed into the links. So you can just click on it and get to the Jira issue out of the box. So how do we actually create that? How to get there? So first, we would need to have a robot framework listener to get the data that we actually then take and transform. So you can see an example there on the slide. It's an output JSON that I used. It includes data about the test case, the name, the documentation tag, start and end times, timestamps, which are really important. The elapsed time, status of the test, which then it's like taken together and computed based on if all the tests are passing or if there is any failure, and the array of requirements. And of course, some metadata for the test run, meaning total test counts, total passed, total failed, scope, release, tester, and so on. So now we have the data and what to do with the data. So for this purpose, to create the report, I utilized Jinja. So what is Jinja? It's a templating engine. It's fast, expressive, extensible. It basically uses a special placeholders inside of HTML file, and you can use inside of those special placeholders a syntax, like the syntax of the code is similar to Python, and then the template is passed the data and the final document is produced. It uses like the template, which is like reviewed by some subject matter expert who knows the policies by heart. So you don't have to really care about what the policies say. You just use the template, which is approved, fill the data in, or actually what the automation pipeline does, it fills the data in for you and creates the final report. And then you just save it, store it, and retrieve it whenever possible or whenever needed. If you scan the QR code, you can display Jinja documentation, which contains like how to use this tool. There is a syntax preview of the Jinja. You can see you can do for loops, you can create tables and iterate on the data that you get from the listener. You can basically use any HTML that's like any HTML possible, so you can use classes, you can use IDs, you can use CSS styling, so whatever fits into the good documentation practices in your company, you can use in here. Then basically you have stored the robot framework file, you have stored the Jinja template in GitHub or whatever storage you prefer. You run it in the pipeline, Jenkins, GitHub Actions, CloudBees, or whichever you use, where the robot framework listener is integrated, and then it produces the HTML or PDF file for you. In case you will need the PDF files, you can also specify some special styling for printing. So in case that the quality unit needs to have it printed and signed by hand, you just print it and it's out of the box. Let's conclude with some key summary and takeaways. It's always good to use automation as much as possible. So it means that if you start using Jinja templates and you fill the data in using robot framework and robot framework listener, you can then expand it and you can use it for basically whichever type of document you feel like. And it can avoid multiple audit failures because of some mistakes that can be done while you are filling the documents manually. No formatting changes need to be done. If you know, when you format Word, it doesn't always go the way that you would wish for. So you don't have to do that anymore. And it reduces the time not only for you as a technical unit, but also for the business and quality representatives, because they know the template, they know how the data or how the document would look like, so they just have a brief glance and know what the result is. Then one of the things that I wanted to express that it would be great to not look into compliance documentation as documents, but more like evidence. So it means that you just have the data, and in whichever way you store it, it doesn't really matter as far as the data is accurate and the data integrity is persisted. And last but not least, the reports that are created should be simple and easy to navigate. So whoever opens up the report, if it's someone who knows the project by heart and works there for 10 years, or if it's some newcomer, they will immediately know what is happening. So with this, I would like to thank you for your attention. If this resonates with you, I have included some examples in the GitHub repository, so feel free to scan the QR code and go through the examples. Thank you.
Thank you, Katerina. You'll get your hoodie later. They didn't supply it to me. Raise your hand if you have any questions. We'll have some time for questions. Anyone? There. Good.
Hey, thank you for your talk.
Thank you.
I was wondering, once you have the information about the covered requirements, do you need to do some analysis afterwards, like if all requirements are covered by your tests, or is that something you don't have to do?
So usually we do regression testing as well, so we usually run the whole test suite. So we just create an increment, we add the 4 stacks, and then we run the whole suite. So we always cover like the whole scope. That's at least what we do. If you want to make sure that you cover everything that is needed, you need to cover at least those that are new, in case that you don't want to do regression testing. But I guess it's up to the team, really, and up to the strategy which is described in the test plan.
Thank you.
I think there's, yeah.
So in a highly regulated environment, there's probably a lot of expectations on the software you're using for testing. Did you find any shortcomings with either like Robot Framework or any of the libraries that you needed to kind of bring up to a higher standard so that you could use it in that environment?
So actually, before we can even use Robot Framework or any library, we need to validate it first, just to make sure that it's like goes through all of this criteria. So if there is something new, sadly we need to wait until one of the divisions validates it. So we always learn about the new things here, and then we need to wait like half a year before we can even use it, before it's like considered really harmless, let's say.
Actually, just a follow-up with that then, could you describe a little bit about that validation process? I mean, is there something special that, or is it kind of handed off to a separate team to handle?
Unfortunately, it's not something that I do, so I can't really describe it. We just handle, like come up with the idea, we give it to the team, and they just work on that, and then say, okay, it's ready for the use.
More questions for Katerina?
So you already answered my other question, like which version of the listeners were using. At what point are you listening to get that data? Are you waiting for the entire test run, or are you collecting it as it goes?
We wait for the whole test run. So I can't recall the port now, but we wait for the whole suite to just end, and then we create the report. So in case it fails in the middle, we just need to rerun.
We have time for 2 more questions if there are any. All right. Thank you, Katerina, for excellent talk. Show some love for Katerina Hosova.